Hello, I'll walk you through my solution of the submission for this hackathon. So the theme I've opted for is to predict the number of aircraft departures. So my motivation or objective of this submission is twofold. A, identify what are the factors which influence the number of aircraft departures, and B, estimate or predict the number of aircraft departures using those identified factors. Ultimately, this whole solution can be used to identify the potential market opportunity of emerging markets not only across Asia Pacific and India but also anywhere across the world. So, for this hackathon, I have used machine learning to predict the number of aircraft departures. And to train the model, I needed the data, and the data I have trained on is basically on the World Bank data. So the World Bank data is available from 1960 till 2021 at a country level. So I created the model by training it on the country level data provided by the World Bank, but I validated that data or validated that model by testing it on the four metro cities of India, that is Delhi, Chennai, Mumbai, and Calcutta, to see whether the model is basically confined to a national level or is it tolerating well at a micro market level. So basically, for this whole exercise, I kind of opted for limited number of input attributes, primarily belonging to demographics, economic, and communication dimension. Although I had availability of data from World Bank belonging to other dimensions, let's say health, mortality, environment, markets, finance, etc. But I kind of opted for these three dimensions. The reason was the data availability at micro market level for these data or attributes. So for these set of attributes, I found that the data availability, at least for the four metro areas of India, was relatively easier as compared to other attributes which were provided in by the World Bank in the input data set. So I kind of stuck to these attributes and try to understand that within these attributes, which are those primary or key attributes which influence or impact the number of aircraft departures. So basically, I tried to understand and run the machine learning model, and the results showed me that the top three attributes or top three primary factors were 60% of the model overall importance. Just the top three factors. And the top three factors were fixed telephone subscription, value added services at current US dollar, value added in manufacturing sector at current US dollar. In fact, as you can see, fixed telephone subscription kind of overpowered the importance as compared to other attributes and is very pivotal in terms of influencing the number of aircraft departure in a given market or micro market level. In terms of machine learning model, I compared three boosting models, your XGBoost, LightBoost, and CatBoost. And the reason I kind of stuck with gradient boosting model is basically for their ability to handle null values relatively better. I tried to compare it with the performance of other models, but the gradient boosting model performed better. So I kind of stuck with these three and tried to see which of these three was performing better. And what I found is that XGBoost fared better than Light GBM and CatBoost in terms of mean absolute percentage error performance. Not only that, once I had this model for these three attributes, I tested it for the four metro cities of India to see what is the deviation between the actual and predicted. So the results were kind of mixed. That is, for Delhi, the deviation was pretty much high, but for Kolkata, Mumbai, and Chennai, the deviation was pretty much okayish or moderate. And the reason I believe is that I kind of constrained my analysis only to these three dimensions. I believe that the more dimensions we add, the more and more we will be able to moderate the deviation between actual and predicted. Uh, in terms of how I kind of went about in terms of execution, you will see there are two Jupyter notebooks in the GitHub repository. If you go to the source code file, you will see there are two Jupyter notebooks, the data pool and model. You can refer to the data pool to understand how I kind of pulled the data. It's basically from the WBG API library, which is provided by World Bank to pull the data. And then I kind of created the model in this underscore model Jupyter notebook, as you can see on the screen. And also I've kind of put it in the source code subdirectory in the Git. One more thing, while comparing the values of the four metro cities of India, I took the values of the actuals from the Airport Authority of India. But the Airport Authority of India reports the aircraft movement. It doesn't report the aircraft departure. So what I had to do is that once I got this data, I divided it by two because aircraft movements would include your departure as well as arrival also. So to kind of get a like-to-like analysis with the definition which we have followed, which is as per the World Bank reported one, which we used to create the model, while validating the data for the four metro cities in India, I halved the values which are provided to them for the year 2019 by AAI. One more thing also, that to validate the metro data, I kind of only validated for the year 2019 because this model tells you the potential opportunity. This model has not yet matured to factor in attributes like mortality, death, which kind of becomes more prevalent for the data from 2020, 2021 onwards, because that's when we had COVID spike up and you had travel slow down completely. So this model, which kind of I am kind of shared, I mean, I have kind of created, or the product I have kind of created, gives a potential opportunity. It doesn't tell basically the real thing. That is, for instance, if an airport has opened today and it has limited capability, the model will predict the total number of airport departure based on that micro market macroeconomic factors, which is fixed telephone subscription, value added services, and value added manufacturing. We are yet to incorporate the airport's infrastructure aspect. And the reason I didn't include the age of the airport is that I tried including the age of the airport here while creating the input data model, but the age of the airport was coming out to be the least important attribute, primarily because all these I was doing the analysis at a country level, and all the countries the data were mature, or the airport or aerospace evolution of all the countries were mature. Not only that, once I kind of created this machine learning model, I deployed it in Azure cloud and created a user interface. So all you need to do is you just need to hit this particular URL, and in this URL, you will get two options: A, to manually enter values, and B, to upload file. So if you click on manually enter values, you enter these values. I mean, you enter the values of the three primary attributes I kind of walked you through, and click on predict, and you will get the total number of airport departures. Now, if you want to do it by uploading a file, simple. You select the second option. You basically have to choose a file. So basically, this is the testing data, and testing data file is an Excel file. As you can see, you have the airport name, you have the total fixed telephone subscription, services value add, manufacturing value add. This I got it from the TRAI, Telecom Regulatory Authority of India. Services and manufacturing, I managed to get an estimate going through the state budgets report of Maharashtra, West Bengal, Delhi, and Tamil Nadu, respectively. So once I had this data, I kind of keyed in, and all you need to do is you kind of upload this Excel file and you click on predict and view. So as you can see, you have the actual predicted values in this particular uh, table. Similarly, you also have a provision not only just to view the predicted data, but also predict and download. A downloaded file will come as a CSV format. So this is basically an ecosystem or tool I have created. And the challenges that I kind of faced while doing this analysis is basically even getting the correct value of those three identified attributes. The validation I've done for India, for APAC, I struggled to get the values of those parameters. As I mentioned, the model reflects potential opportunity and does not includes factors at airport capacity or infrastructure level. Uh, and in terms of opportunity or next step forward, I'm looking to include additional features which I've kind of excluded right now because they were difficult to access. I'm trying to see which of the other dimension I'm able to access and then see whether the model performance is improving. Also to automate the whole process, that is end-to-end data streaming and model building, model training pipeline. Of course, customer feedback loop, that is from the customer experience perspective. If the prediction is not great, then have a provision here where the customer or the end user can say, hey, the prediction is not satisfactory, and we can review those cases. And yes, of course, as I mentioned, the validation I've done is only for the four metro cities in India. Validation for APAC airports and tier 2, tier 3 cities of India and across different years is still a step forward. So this is basically what I kind of have kind of created the solution. And that's it from my side. Thank you.